Risk and rate of return. Risk is uncertainty that matters because it affects people's investments. There are two ways of risk analysis, including standalone and portfolio context. Standalone risk is measured when an investor has only one asset, and portfolio risk is measured for a combination of assets. Risk is either systematic or non-systematic. Systematic risk is market risk and it is non-diversifiable. That means it cannot be eliminated by diversification, such as war, recession, weather, inflation affects everything, so diversification does not reduce the risk. Non-systematic risk is diversifiable risk. It is unique to an asset. That means it is asset-specific risk. It can be eliminated by portfolio investment. It is a non-market risk. Let's see how to measure the volatility of rate of return. This volatility of rate of return can be shown by variance of returns or standard deviation of returns, where because standard deviation is a positive square root of variance, we can just find variance, and then that can be a standard deviation also. So standard deviation sigma square is summation of I equal 1 to n required rate of return minus estimated rate of return squared times probability of investment I, right? And then again the square root after you found the square variance sigma square, that is standard deviation. Right? Well, in the spreadsheet, in the Excel sheet, we can find out, for example, with this example, we can find variances or standard deviation. Economy can be strong, normal, and weak. The probability of having strong economy is 30%, the normal case is 40%, the probability of having weak economy is 30%. When probabilities are given, you are going to use this formula to find out variance. If you go back to your statistics book, then your book can give you a different formula for standard deviation. And that is when probability of each possibility is not given. So, there are two formulas to find out standard deviation. So again, when probabilities are given, you are going to use this formula. Okay. So here in this Excel sheet, rate of return if this demand occurs, and then strong means rate of return is 80%. Normal return means 10%. When economy is weak, the rate of return is minus 60%. Deviation, we find deviation, that means 80 minus, in this case, deviation actual, this 10% is estimated rate of return. This R square, R hat, that's estimated, in this case, estimated. That means, well, actually weighted average. So 80 minus 10% is 70%. 10% minus 10% is 0. Minus 60% minus 10 is minus 70%. And then you scale these numbers. Scale, then you get 0.49, 0, and 0.49 here. And then multiply by probability. Then multiplied by 0.3. That's probability of having a strong economy, right? And then you get this number. And here multiplied by 0.4, 0, multiplied by 0.3, you get 0.147. And you add all of these up, and this number is variance. This is sigma square, little sigma square. That's variance. And then square root. Now, and then square root that number sigma square 0.294. This is 0.5422. In other words, that's 54.22%. That's standard deviation. Okay, this is how to find standard deviation to figure out standalone risk. Then this this graph shows the risk. Risk is shown graphically here. This company's stock shows expected rate of return 10%. This company's stock also expected rate of return 10%, but possibility of this stock is wide, right? From minus 60 to 80. And then this stock is very narrowly distributed, so it is less risk, right? This stock shows a higher risk because it shows a higher, well, larger standard deviation. Now, the second method is called the coefficient of variation, CV, where the formula is standard deviation divided by expected rate of return. Expected of return. Well, really, we can find out the expected rate of return by weighted average. Right here. Let's look at, well, why not just use standard deviation? Let's say, let's look at this example here. Stock A's average return is 16, and the standard deviation of that return is 30%. Let's say this is percentage numbers. Standard deviation also 30%. But stock B's average return is 20%, and then standard deviation is 30% also. Should we say stock A and stock B have the same level of risk? Well, that's very hard to say that because their average returns are different, right? So in this case, we use a coefficient of variation. So coefficient of variation here is CV is standard deviation 30% divided by 16, right? That gives me 1.87. And then this case, 30 divided by 20, right? Average return. And then that gives me 1.5. So we can say This is riskier, right? Stock A, because average return is lower and still have the same level of standard deviation. Another method is, well, in your textbook, this is also introduced, Sharpe ratio, is return minus risk-free rate, the difference between asset risk rate of return and risk-free rate of return, right? And then it is measured using standard deviation. So it is measured, the rate of return is measured by in terms of standard deviation, right? In terms of standard deviation, so it is kind of normalized, and then we can figure out across, we can compare the risk across individual investments. Now this table shows a higher return means higher risk. See, small cap stocks has higher level of average return, and then it shows a higher standard deviation. That means a higher risk, right? Then large cap stocks, larger companies, returns less than small cap stocks, and then it is safer than small cap stocks in terms of standard deviation. See, U.S. Treasury bill returns were lower, right? Lower than other private company stocks, and then its standard deviation is lower. That means safer. Okay, so this is a good example of the relationship between higher return and higher risk. Now, let's talk about beta coefficient. In textbook, this is written like this, lowercase b. Beta coefficient is a measure of sensitivity of assets return to changes in the value of entire market of assets. So greater beta means greater systematic risk. Now, we are not going to calculate beta coefficient for each individual company's stock. Instead, it is estimated empirically by professionals. Value line reports periodically all betas of 500 big companies of the United States. Now, hedging, insuring, diversifying are good methods of risk management. Portfolio is to diversify, that is, mix stocks or bonds whose rate of return are moving in some opposite direction, even if it is not exactly opposite. Your textbook shows a good example of this diversification, which is called WM investment. This is coefficient of correlation. It should be -1 or near -1, such as -0.8, -0.7, like that. That means the minus sign means opposite direction. Okay, such as graphically, let's say the market price, stock A. When stock A price goes up, stock B's price can go down. When stock A's price goes down again, it tends to go up like that, like this. opposite direction like this. So it says it looks like MW, right? MW investment. Yes. In this case, these two stocks should show two stocks coefficient of correlation should be -1 or near -1. So now we know risk effect required rate of return. To invest into high risk assets, investors will require high rate of return. Capital asset pricing model, we call it CAPM, shows that relationship. So it shows the relationship between risk and required or expected rate of return. And risk premium is involved here. And risk premium is risk premium on market. Risk premium of market is calculated like that. When beta is 1, RM rate of return in market, that is average rate of return in the market. That is return of market minus return of risk-free, right? Risk-free. That difference multiplied by beta 1 is called risk premium of market. It is average risk in the market. So risk premium on a certain specific stock is computed like that stock's beta times, this is what? This is risk premium, right? Yeah, average risk premium, right? This is risk premium of market. Now, required rate of return on the stock S is expressed by SML equation. Rate of return of stock S equals risk-free rate of return, okay, plus market risk premium, right? RM sub M minus RF, right? Times this beta. This is beta for that stock S. Okay. And then, this is actually RS, right? Required rate of return. And this is called SML line, SML equation, security market line, right? Graphically. So this is security market line, required rate of return, or we can say, well, expected rate of return is risk-free rate of return plus market premium, right? Market risk premium multiplied by the stock's beta. Okay, this stock beta is labeled here on horizontal line, and vertical line is required rate of return. So if beta goes up, the slope of this line goes up. It looks like this, higher beta. Higher beta. And also, if risk-free rate of return is lower, then it can go down like this, right? So we can understand the graph. Financial information many times are reported graphically, so we need to understand what graph is. Now, portfolio beta is computed by weighted average of individual betas. Let's look at one example here. A portfolio investment consists of 4 stocks. Risk-free rate of return is 2%. Market risk premium is 3%. Then, what is portfolio beta? And then, what is the required rate of return of this portfolio investment? First of all, we need to figure out portfolio beta. Each stock's beta are given, right? It's given here. So we want to find out weight of stocks A, B, C, D, right? And then the total is 1 million, 2 million, that's 3 million and $4 million, right? Total is $4 million. And then 400,000 over $4 million is 10%, right? 10%. And there is, and then here 600 over 4,000. And then this is 10% multiplied by 1.6 is 0.16. Here, the 600 divided by 4,000. Let's say that 4,000 is 4 million here. Multiplied by minus 0.5 is minus. I get minus 0.075. And 1 million over 4 million, that's a quarter. So 0.25 times 1.25, that is, I get 0.3125. And then 2 million over 4 million, that's half, right? That's a half times 0.75 gives me point, and then we add them up. Okay, so portfolio beta is 0.7725, right? What is the required rate of return of this portfolio investment? This is required rate of return of risk-free rate plus risk premium of market times beta, right? So risk-free rate of return is 2% given here, plus market risk premium is 3% times beta is here. Portfolio beta is 0.7725, right? That gives me 2% plus that 0.03 times that is 0.0232. So this is 2.32%, right? So it is 4.32%.